Hello everyone, welcome back to Husky Math. Today we will learn about homogeneous differential equation. Before that, we should know what a homogeneous function is. So if there is a function of x and y where the expression is x square plus y square minus xy. This is just an example, okay? So here as you see, the power of x is 2, the power of y is 2, and the individual power of x and y are 1 and 1, but all together if we add those 1 and 1 we will get 2. That means the power of this particular term is also 2, the power of second term is also 2, and the power of this term is also 2. That means each term is of degree 2. So if this kind of expression where each and every term has same degree, then that type of function is called homogeneous function. Let us see one more example. Suppose there is a function of x and y where the expression is x cubed minus 3xy square plus 3x square y minus y cube. So here if you see that each and every term, that is this first, second, third and fourth term is of degree 3, because here you can see the power of x is 3, here the power of x is 1 and the power of y is 2, but altogether the power is 3. So this kind of function where each and every term has same degree, then that type of function is called homogeneous function. Now let's come to what is homogeneous differential equation. So if there is a differential equation where this dy over dx is written as function of x and y divided by g of x and y, where this function at numerator is a homogeneous function and the function at denominator is also a homogeneous function. And if we express dy over dx in this kind of ratio where the numerator and denominator are the homogeneous function, then that type of differential equation is called homogeneous differential equation. Here if you see that the order of this differential equation is 1, since there is first order derivative and it has power of 1, so the degree of this differential equation is also 1. Hence it is a homogeneous differential equation of order 1 and degree 1. How to show a differential equation is a homogeneous differential equation? Say all differential equation may or may not be a homogeneous differential equation. So some equations are only homogeneous differential equation. So how to recognize that type of equation? For that, we have to express the given differential equation in the form of dy over dx equals to function of y over x. Here you see that this dy over dx is a function of y over x. That means we should have ratio of y divided by x. So that means this dy over dx depends on the ratio y over x, and this x and y are not separate here. So in this chapter, we will try to show a differential equation is homogeneous or not, and after that, the question will also ask to solve that differential equation. So here are 3 steps which we have to follow in order to solve homogeneous differential equation. So in the first step, we see that first we will have to suppose y equals to v of x, where this v is a function of x. So in the second step, we have to differentiate this y equals to vx with respect to x, both sides. So differentiating this, we will have dy over dx equals to, since v is a function of x and x is obviously function of x, so here we have to use the product rule, and on using that, if I keep v first, then derivative of x is 1, plus keeping x first, then we have to differentiate v with respect to x. Now we have to substitute back the value of y and dy over dx in the original equation. That means we have to write y equals to vx, and instead of dy over dx, we will write v plus x into dv over dx in the original equation, and after that we have to solve that particular equation. So it will be clear if we see some examples. So let's start with few questions. Question 1. So that the given differential equation is homogeneous and solve it. First we will show this equation is homogeneous, and after that we have to solve also. So in order to show this equation is homogeneous, let us divide both sides of this equation with x. So dividing both sides with x, we will have dy over dx equals to y over x log of y minus log of x plus 1. So this implies dy over dx equals to y by x. And here, if you see, log of y minus log of x can be written as log of y by x plus 1. Now, if you see this equation, this dy over dx is now a function of y over x. Now, this dy over dx is a function of y over x. So, since dy over dx is a function of y over x, that means this equation is homogeneous, that is proved. And let this be our equation 1. Now, the second part is to solve this differential equation. So, to solve the differential equation which is homogeneous, we have learned few steps. So, the first step is to assume the value of y equals to v into x, where this v is a function of x. Now, let us differentiate both sides with respect to x. Then we will have dy over dx equals to, using the product rule here, keeping v first, ddx of x is 1, plus keeping x and differentiating v, we will have dv over dx. Now, we will substitute the value of dy over dx in equation 1, and from here you see that this v is nothing but it is a ratio of y over x. So, instead of y over x, we will be writing v in equation 1. These two things we have to substitute in equation 1. So, substituting the value of y over x and dy over dx in equation 1, then this particular equation will be, instead of dy over dx, I will write v plus x into dv over dx equals to y over x is v into log of y over x is v plus 1. So, my differential equation has two variables now, that is v and x. Now, we will solve this differential equation by the method of separating the variables, which we have learned in the previous videos. So, here this implies v plus x into dv over dx equals to, opening the bracket, v into log v plus v into 1 is v. So, here this v and v got cancelled, implies x into dv over dx equals to v log of v. So, separating the variables, we will have dv over v into log v equals to dx over x. So, now since the variable has been separated, now we will integrate both sides. So, integration of dv over v into log v equals to integration of dx over x. And in order to solve this integral, we will use the method of substitution. That is, for that we will put log of v equals to t, and differentiating with respect to t, we will have 1 by v dv equals to dt. So, my equation becomes, from here, integration of dv over v is dt and log of v is t equals to integration of dx over x. So, this implies integration of dt over t is log of t equals to integration of dx over x is log of x. And after integrating, we have to add the constant of integration. So, but here we will be writing log of c. So, on doing so, here let us put back the value of t, that is log of v equals to log of x minus log of c can be written as log of x into c. So, here since there are log on both sides, so we can write log of v equals to c into x. So, it will be log of y over x equals to c into x. So, this implies y over x equals to e to the power cx. So, you can operate both sides by with exponential function. So, that means the value of y, or the solution of this differential equation which is homogeneous, is x into e to the power cx. So, you might get a little bit confused, but be with me and let us see few more questions, then I think it will be much easier afterwards. Question 2. So that the given differential equation is homogeneous, and afterwards we have to solve this. So here this implies x square into dy. Let us write this term on the other side, then it will be minus y into x plus y dx. So dividing both sides by dx, then we will have x square dy over dx equals to minus y into x plus y. So dividing both sides by x square, now we will have dy over dx equals to minus, let us open this bracket, then here it will be xy minus y square, and here in denominator we will have x square, that is we are dividing both sides by x square. So this implies dy over dx equals to, let us separate the denominator, then xy by x square minus y square by x square. So here x and this square got cancelled, so the value of dy over dx equals to minus y by x, and minus this y square by x square can be written as y by x whole square. Now since here you see that this dy over dx has been expressed in terms of y over x and y over x, that means this dy over dx is a function of y over x. Hence this differential equation is a homogeneous differential equation. Now the second part is to solve this equation. For that, let this be equation 1. And the step to solve this homogeneous differential equation is we have to assume y equals to v into x, where v is a function of x, and from here y by x means v. This we will require. And let us differentiate this equation both sides with respect to x, then we will have dy over dx equals to, using the product rule, it will be v plus x into dv over dx. Now we will substitute y over x as v and dy over dx as v plus x into dv over dx in equation 1. So from this equation, dy over dx can be written as v plus x into dv over dx equals to minus, there is y over x, you can see here, so this y over x is v. So here it is minus v minus y by x whole square, that is v square. So this implies, let us take this v on the other side, then we will have x into dv over dx equals to minus v, and minus v will be minus 2v minus v square. This implies x into dv over dx equals to, taking out minus v common, then we will have v plus 2 inside. And let us now separate the variables, then we can write this as dv over v into v plus 2 equals to minus dx over x. Since the variable has been separated, now we will integrate both sides. So now in order to integrate this left hand side, you see that we use the concept of partial fraction here. So that part I am skipping here because we have already learned how to do the partial fraction. So on doing so, we can write this integration as, or that fraction as 1 by 2 into 1 by v minus 1 by 2 into 1 by v plus 2 into dv equals to minus integration of dx over x. So taking out 1 by 2 common, it will be integration of 1 by v dv minus 1 by 2 is constant, integration of 1 by v plus 2 into dv equals to minus integration of dx over x. So the integral of 1 by v dv is log of v minus 1 by 2. Integration of 1 by v plus 2, if you do by substitution, or you see that the denominator is linear, so we can directly write this as log of v plus 2 equals to minus log of x. And here let us write the constant of integration as log of c, since there are log on each and every term. So this implies log of v to the power half using the property of log minus log of v plus 2 whole to the power half equals to, here using the property we can write log c minus log of x as log of c by x. So this implies log of a minus log of b is log of a by b equals to log of c by x. Since there is log on both sides, so we can write this as v to the power half by v plus 2 whole to the power half equals to c by x. Now let us square both sides in order to get rid of this 1 by 2. Then we will have v over v plus 2 equals to c square over x square. Now let us put back the value of v, that is y over x. So we will have y by x divided by y by x plus 2 equals to c square by x square. Simplifying, we will have y in the numerator, and in the denominator we will have y plus 2x equals to c square over x square. So on cross multiplying, we will have x square y equals to c square into y plus 2x. So this is the required solution for the given homogeneous differential equation. Question 3. So that the given differential equation is homogeneous and solve it. So first we will show this equation is homogeneous. For that, let us take this first term to other side. So here we will have this equals to minus 2xy dx. So dividing both sides by dx, we will have x square plus 2y cube. Sorry, this is square. dy over dx equals to minus 2xy. So this implies dy over dx equals to minus 2xy whole divided by x square plus 2y square. Now on the right hand side of this equation, we will divide the numerator and the denominator with x square. So dividing the numerator and denominator with x square, then we will have 2xy by x square whole divided by x square plus 2y square by x square. So that is the value of dy over dx. We are trying to show that this equation is homogeneous. So dy over dx equals to, here you see that this x and square got cancelled. So we have minus 2 and y by x in the numerator whole divided by, if you separate this x square which is at the denominator, then we will have 1 plus 2 into y by x whole square. Now you see that this dy over dx is a function of y over x. That's why this is a homogeneous differential equation which has been proved. And let this be equation 1. Now we have to solve this equation by assuming y equals to v of x and differentiating both sides with respect to x, we get dy over dx equals to v plus x into dv over dx. See, the steps are same in each and every question. So from here we can write y over x as v. So let us put these two values, that is y over x as v and dy over dx as v plus x into dv over dx in equation 1. So substituting these two values in equation 1, we have on the left hand side of equation 1 as v plus x into dv over dx equals to minus 2y over x is v by 1 plus 2v square. So now let us try to separate the variables. Equals to minus 2v by 1 plus 2v square minus v. Let us take LCM on the left hand side. Then we have x into dv over dx equals to minus 2v minus v into 1 plus 2v square whole divided by 1 plus 2v square, taking LCM and simplifying. So on simplifying the numerator here, we will have equals to minus 2v and minus v is minus 3v minus 2v cube whole divided by 1 plus 2v square. So let us take out minus common. Then here we have x into dv over dx equals to minus 3v plus 2v cube divided by 1 plus 2v square. Therefore, so on cross multiplying and trying to separate the variables, we can write this everything as 1 plus 2v square will come at numerator divided by 3v plus 2v cube at denominator into dv equals to minus, and on cross multiplying we will have dx over x here. Now let us integrate both sides. Before that, if you see that here in the left hand side we will multiply and divide with 3. So on doing so, we will have 1 by 3 into 3, 1 plus 2v square by 3v plus 2v cube into dv equals to minus dx over x. See, the purpose of multiplying and dividing with 3 is that let us first open the bracket, then I'll explain. So multiplying the numerator with 3, we will have 3 plus 3 to the 6 v square, and here in the denominator we already have 3v plus 2v cube into dv equals to minus dx over x. Now let us integrate both sides. Then here if you see that here in the numerator, that is 3 plus 6v square is the derivative of 3v plus 2v cube. So now we will suppose this denominator to be t. So let us put this to be t. So put 3v plus 2v cube equals to t. Now if we differentiate both sides with respect to v, then we will have 3 plus 2 3 is 6 v square into dv equals to dt. And if you notice that in the numerator we have 3 plus 6v square into dv. For that purpose we were multiplying and dividing by 3 in this step. So the integral will be 1 by 3. Integration of numerator is dt and the denominator is t equals to minus dx by x. So this implies 1 by 3. Integration of dt over t is log of t equals to minus integration of dx over x is log of x. And let us add constant of integration, writing log of c. So using the property of log, this can be written as log of t to the power 1 by 3 equals to here log of c minus log of x is log of c by x. So there's a shortage of space here. So let us continue here. So since there is log on both sides here, so we can write t to the power 1 by 3 equals to c by x. In order to get rid of 1 by 3, let us cube both sides. Then we will have t equals to c cube by x cube. Now let us put back the value of t, that is 3v plus 2v cube from this equation equals to c cube by x cube, and putting back the value of v, that is y by x, we will have 2 into y cube by x cube equals to c cube by x cube. Here let us take the LCM, then we will have x cube in the denominator, and here we will have 3x square y plus 2y cube equals to c cube by x cube, and this x cube got cancelled. Hence the final solution for this differential equation is 3x square y plus 2y cube equals to c cube. Question 4. Here let us keep dy over dx here and take everything on the other side. We will have y minus x into sine y by x. Dividing both sides by x, then on the left hand side we will only have dy over dx equals to dividing by x, and dividing by x, this x and x get cancelled. then we will have sine y by x. So it is clear that this differential equation is homogeneous since dy over dx is a function of y over x. Now let us solve this equation. For that, let this be equation 1. So our first step is to put y equals to v of x, and differentiating both sides with respect to x, we will have dy over dx equals to, using the product rule, we will get this much, and from here the ratio y over x equals to v. Now let us put the value of y over x as v and the value of dy over dx as v plus x into dv over dx in equation 1. So from equation 1, on the left hand side we will have v plus x into dv over dx equals to y by x is v minus y by x is v. So here this v and v got cancelled. So let us separate the variable also. Then we will have dv over sine v equals to minus dx over x. So let us integrate both sides. So integration of 1 over sine v is cosec v dv equals to minus integration of dx over x. So the integration of cosec v dv, we have more than one formula, but here we will be using that the integration of cosec v dv is log of tan of v by 2 equals to minus log of x and adding constant of integration, that is log of c. So this implies log of tan of v by 2 equals to log of c minus log of x is log of c upon x. So since both sides are log, so we can write this as tan v by 2 equals to c by x. Putting back the value of v, that is tan y by x, so here it will be y by 2x equals to c by x, and hence the solution for this equation is x into tan y by 2x equals to c. Question 5. Find the particular solution of the differential equation. So here we have given that y will be pi over 4 when x equals to 1. That means we can find the value of constant of integration. First, let us show that this differential equation is homogeneous. Though the question has not asked us to show, but this is a homogeneous differential equation. For that, you can see that there is y by x inside this sine square function. So let us try to show that this is homogeneous. So for that, let us keep x into dy here and take that first term on the other side. Then we will have x sine square y by x minus y into dx. So x into dividing both sides by dx, and opening the bracket, let us write positive term first, that is plus y minus x sine square y by x. Let us divide both sides by x, then we will have dy over dx equal to dividing by x sine square y by x. So it is clear that this dy over dx is a function of y over x. That means this differential equation is homogeneous. And let this be equation 1. So to solve, let us put y equals to vx, and this will give dy over dx equals to v plus x into dv over dx, and from here y over x is v. Let us substitute these two values in equation 1. Then we will have v plus x into dv over dx on the left hand side, and on the right hand side we will have v minus sine square of v. So this v and v got cancelled, and separating the variable we will have dv over sine square v equals to minus dx over x. So this implies, let us integrate both sides. Then integration of 1 over sine square is cosec square v dv equals to minus integration of dx over x. So integration of cos x square v is minus cot of v equals to minus log of x, and for our convenience let us write minus c. On doing so, we will get rid of this negative signs, so we will have cot of v equals to log of x plus c. Putting back the value of v, cot of y over x equals to log of x plus c. Now this is our general solution, but since the question has given the value of x and y, so we can find the particular solution. So putting the value of x equals to 1 and y equals to pi by 4 in this general solution, we can find the value of c. So let us put that. So here it will be cot of the value of y is pi over 4 and the value of x is 1, so divided by 1 will keep the same thing. Log of the value of x is 1 plus c. The value of cot pi by 4 is 1 equals to log 1 is 0 plus c. Hence the value of c is equal to 1. So let us substitute this value of c in this general solution. Hence the particular solution for this question will be cot of y by x equals to log of x plus c is 1. So this is the particular solution for this homogeneous differential equation. So this much in this video. I hope you came to learn what is homogeneous differential equation and how to show it and how to solve it. So there are plenty of questions in your textbooks, so you go and try solving those questions. So see you in next video.